So let's look at the second one here. Let's see. Let me do this. All right. So we're going to read through number 2. This is number 1, sort of bleeding over. By the way, does it make sense to you that the rate at which the radius is growing depends on how big the radius is currently? Because I'm pumping the same amount of air in. As it gets larger, it would take more air to make it grow as fast as it was, right? You guys kind of with me? Which is why there was a movie where volcanoes started coming up. It's like an old movie. I can't remember. Tommy Lee Jones was there. And somebody said the temperature of the lake rose 1 degree. And somebody else was like, what's that matter? It's because the amount of water in the lake meant a ton of heat must have gone in to make it change that much. I don't know if you guys are with me or not, but the larger this thing gets, the slower it's going to grow. The rate's going to grow because there's more volume. It's a bigger volume, but I'm pumping the same amount of air in. Maybe. So you're going to see this kind of thing in the homework a lot. They're going to tell you, how quickly is this changing when the value of this is this? Why is that important? 2 things. 1, what we just talked about. Physically, it makes sense. 2, mathematically. You're going to have the variable show up, so you're going to have to know what the hell the value of it is. So mathematically, it's showing you, hey, it depends on what the value of this currently is. So this problem is much nicer than number 1. Why is this problem so much nicer than number 1? Say again? Yes, this equation that we used, we had to come up with it. And that, of course, is the worst part of any word problem, is trying to take the information and put it into an equation. So celebrate when the problem gives you the formula you're working with. Yes? So can somebody tell me, what are the symbols for what they tell me? What symbol would I use for 4 cubic centimeters per minute? What symbol would I use to represent this? So there's 2 ways to kind of work this out. I'm pumping air in, that should increase the volume. But if you look at the units, that's the biggest giveaway. Cubic centimeters is volume, yes? And then of course minutes, you're not going to believe this, that's some time. It's crazy. You guys kind of with me? The d whatever, dy, dx, d theta, dt, that kind of thing, that kicks so much ass in terms of interpreting units, but also if you have something with units, it's telling you what the shit it is. It's change in volume, change in time. Thank you, problem.
That's so nice.
Do you guys see that? Do you guys see that? Do you guys see that? Units are not just some extra shit we put on just to screw with you. Do the units. No, they're helpful. They're crazy helpful. So, dv dt. My first step in these kind of problems, one of my first steps is identify what they tell me. Make this big. dv dt is 4. What are they asking me for in symbols? dr dt equals, I don't know. So if I set up an equation and I end up with no dr dt in it, I know I must be wrong, because then I can't figure out what dr dt is.
We already have the equation for volume, so we just need to derive
Yes. So Ezekiel, I love you, man. You're over there going, dude, this shit you don't want about. Let's just do the problem.
Yeah, I mean, we have an equation, so we just need to
Totally.
figure out.
Now you understand this first step is really important. Identify what they tell me, identify what they ask me. So now we're going to do like Ezekiel said. It's just like number 1, except we were given the equation. What is this equation's purpose?
What is the relationship between the volume and radius?
Okay, Paola, it's almost like I fed you that. And it says, say this at this time on earth. Right? It's a relationship between volume and radius. You with me? Now, on one level, you're like, well, yeah, I didn't know that's what you guys come with. So if I take derivatives, like you said, I'm going to end up with a relationship between rates of change. And again, I said the title. Ooh, go crazy. Related rates. That's why we call it related rates. It's a relationship between the rates of change. If I know how the variables are related, I just take a derivative. Now I know how the rates of change are related, and then it becomes algebra. On these kind of problems, there are most often there's one calculus step, and every other step is algebra. I know you guys don't believe me, it's okay. So if I take this, and what is this, by the way? Snapshot. That does not come into play until I've taken a derivative. If you plug it in, you get a number, you take a derivative, you get 0, everything in the universe is 0, then you just lay down on the ground, become a nihilist, and let people walk over you. Nothing means anything. So don't do that. Don't do that. Take a moment and take the derivative of that volume formula. With respect to what? Time. Everything's telling me everything's with respect to time, right? So much liquid. All right. So, I'll do this side. What's the derivative of this side? Yeah, the 3 comes down. Multiply by 4/3 is 4. Pi r squared times dr dt. This part would be dv dr. Let me say that again. Bye. This part would be dv dr. You guys see that? In fact, this is what I should have done. Oh man. Someday I'll be a good enough teacher to do this, right? Watch this. Don't worry. What's dv/dr? What's dv/dr?
4/3.
Yeah, the 3 comes down times 4/3 pi r squared. Now, if I did put something here, it'd be dr/dr. That would just go to 1. Yes. So it's the same thing as if I made rx. And I was just asking to take the derivative with respect to x, yes? It's pretty cool with this. Now watch. This is dr dt, yeah. Dr dt, yes? This is dv dr times dr dt. What cancels?
The dr.
And what do you get?
dv over dt.
dv dt, which is what it's supposed to be, correct? So that is how these symbols go further and actually explain the chain rule requirement. If I didn't multiply by dr dt, I'd have dv dr equals dv dt, and that's obviously wrong. But if I have dv dr times dr dt, that becomes dv dt. That equation is true. Do you actually have to use what I just said ever in your entire life? No. Unless you take out 3. And you'll be using what I just said a lot because you'll have a lot more variables and shit gets weird. We're not multivariable yet, so we're okay. So then what do I do now?
Times it by d.
Do I have what they told me showing up? Is what they're telling me. What did they tell me? They told me dv dt. Is it there? Yes. They told me r. They told me the snapshot r. Is it there? Yes. If it wasn't there, would that be the end of the world? No. In that case, if that r squared wasn't there, then the change in volume would not be dependent on the current radius. But it is, like we talked about earlier. It makes physical sense that it is. So they told me r. We know r. I see dv dt. We know dv dt. I'm trying to solve for dr dt. So I got everything they told me and the one thing they asked me. Now it's algebra, right? Plug and shove. One semester, a student had never heard plug and chug, and they were wondering what the hell I was talking about. They're like, "Are you able to say that?" Okay. So what's DVDT? 4. Yes. And what's R?
3.
3. That's the snapshot of 3.
9.
And then I can solve for DRDT. Yes. So I divide by what?
4. Oh, DR. 4.
Yeah.
5.
3 squared is
9.
9 times 4 is
Uh,
36. I divide by 36 pi on both sides. So DRDT equals 1 over 9 pi, and then you can give me an approximation. I don't know what I screw up with, guys. Let me see. It's 1/3 of 1/9, which is like 0.03, and then a little less than that. So I don't know. 1/3 of 1/9, roughly. I'm gonna say 0.027. 0.035. I went the wrong one. Damn it. 0.035. What are the units on that?
The radius of
Yeah, what's the radius in
centimeters over
per
minutes.
minute? That's the established time, yes? Do you see how much this notation kicks ass? R is in centimeters, time is in minutes. So what's the units? Centimeters per minute.
0.349. That's point.
Point.
There's an extra 0 in there.
Oh, okay, sorry. No, it should be, no. Yeah, 1/10 would be 0.1, and then divided by another thing, it should be 0.03. Yes? Alright, I love this dissension in the ranks.
1 over 9
Ooh.
pi, right?
So. Oh, of course I pick you. Get out of here. I picked my one calculator that doesn't want to work. Do you have a battery? Yes. 1 divided by, parentheses, 9.
You gotta put it in
pi,
parentheses. Don't make that mistake.
0.035.
Yeah, you have to put it in parentheses.
0.035. Is everybody able to get that? So again, 1 divided by 9 pi. If you do this, 1 divided by 9 pi, what's the calculator gonna do?
It's gonna.
It's gonna divide 1 by 9, and then it's gonna multiply the result by pi. You guys good? You guys see the difference? Do you guys really see the difference?
Yes.
This thing knows order operations, which means whoever's using this damn thing better know, please excuse my dumbass son, right? Or dear Aunt Sally, whatever you like. You guys good? Did he tell you about the dumbass son thing? Did he tell about the other thing, the deficient algebra skills? One of my classes came up with that. Do you guys understand that you have to know, watch this, what is -2 squared supposed to be? What do you get when you square -2?
4.
No, what do you get when you square -2? Positive 4, but the way I wrote it in here, of course the answer is -4. That's my mistake. If I want to square -2, I better tell the square, I want you to square the whole thing I just plugged in. What does this do? What's 2 squared? And then put a negative on it, so that's what it did, right? If you do this, then you get +4. Is everybody with me? Garbage in, garbage out, yes? Gigo. Okay. And just to make sure you understand this, if you have a follow-up question, you can ask. But I see perplexed faces, and I'm not sure what the perplexity is, so I'm not gonna guess. Okay. So that problem was a classic, straightforward, nuts and bolts related rates problem. They gave us the formula, we took a derivative, and then we just plug shit in and solve for what we wanted. Yes? So here's one that's not so straightforward. Oh, I'm sorry, part B. I forgot about this. You guys understand how part B? All right. How do you do part B? What is the question asking me for in simples? So what am I going to do with this? Yeah, right?
And what did we just figure out up here? DRDT is not going to show up when we do this. All right, so once again, I'll do half of this. What do you get when you take the derivative of this side with respect to time? Yeah, the 2 comes down.
8 pi r.
8 pi r times. And we know what DRDT is. And we know what r is. So then it's just plug and chug. Yes?
So part B is like, go back in time and pretend that I didn't ask you about the volume, I asked about the surface area, right? So instead of taking the derivative of the volume, we take the derivative of the surface area, but part A did give us what DRDT is, which is what I need here. To figure out DSDT, I have to know what DRDT is. So many guys do these problems and you don't draw a picture when it would be helpful. You don't identify in symbols what I tell you, what I ask you. If you do those things, it'll kind of guide you in the direction you need to go.
Okay. So now, I mean, I almost don't care. It's a plug and chug thing now, right? 8 pi times 3 times 0.035 roughly, and then you just multiply that out. 1/3 would be 2.4. Huh?
Since you have pi on the numerator, will you plug in the 1/9 pi just to?
Yeah, I love it. Even better. Paola, you are after my heart so much here. Look, you can put in here, DRDT is exactly 1/9 pi. So if you put that in there exactly, these cancel, these reduce, then you get 8/3. But if you didn't think to do that and you put in the approximation, that's fine also. But that is preferred. So I love it. Thank you. When you can, use exact values for things. What does exact mean? Everybody hears that word and thinks it means decimals. Almost always it doesn't mean decimals. 1/9 pi is exact. 0.035, I don't care how many decimals you take it out to, is always going to be approximate. Because you have to stop somewhere. You get tired. You run out of paper. So this is one kind of related rates problem where I just give you the equation, you take derivatives, you plug stuff in the right place, and you get the answer. Yes? So that's one kind of problem I can do. Yes?
How come it's 8 pi r?
Oh, because what's the derivative of 4 pi r squared?
Oh, yeah.
Yeah, derivative of this is there, derivative of this is there. Yep. Okay. So if I give you a problem like this and I tell you the formula, just go, thank you, Jeff. You must have been in a good mood. Now, you know I'm not gonna only give you that. I'm gonna give you one like this. All right, this is the most exciting problem. So I've got a conical tank. And it kind of is situated like this here, yes? Because radius at the top is 20 feet. You guys with me? As you move along a cone, what happens to the radius at any height? It gets smaller until at the very tip, this radius is, because you got a point, yes? Is everybody with me? It's barely mathematical. You got a cone, you go down the bottom. Of course, if I cut, I'm going to get smaller and smaller and smaller circles until at the tip it's 0, yes? There's no radius at that point. Let me stop for a minute. Do you actually have to think about what I just said ever to do this problem? No. But it makes the problem make more physical sense. If I drain it out of this conical tank, as the water level goes down, it's going to go faster. Does that make sense? When you're at the top, you got a lot more water kind of like sitting on the top, so it takes longer to drain that. When you get down further, now you got less and less and less surface area water. It's going to go faster. Even if that doesn't make it doesn't matter. You don't even have to know that shit. You don't have to know that ahead of time. You're going to find it out in the work. So let's do this.
The two first steps. One first step is always, what are the symbols for what they tell me and for what they ask me? So let's do that first. We have to kind of pick some stuff though. What do you guys want to use for the radius? What variable? R. By the way, let me be careful. Why do I need a variable for the radius? Isn't it 20 feet at the top? What do I need a variable for the radius for? Because what's happening in this problem?
It's getting smaller.
The water level is decreasing, right? Wherever the water is, isn't the top of it a circle? Will it have a radius of 20? Will it have a radius of 20?
No.
Only if it was at the top. If it's any other depth, it's going to have a different radius. Are you with me? So is R changing over time? No. Yes. Because as you go down, doesn't this cross section get smaller and smaller circles? Yes. Is the height changing as I let the water drain out? Water. Sorry. The high quality H2O as I let that drain out. Is the height getting? Yes, the height's very directly changing. You with me? If this was a cylinder, would the radius change?
No.
Then I wouldn't need a variable for it. I could just put the number in. You guys see the difference? Everything that is changing over time needs a variable. So what variable do you want to use for radius?
R.
R. And what about for height?
Height.
Man, I want someone to go, why, math boy? Do you would have been like, cool. And of course, this is what is this talking about physically? What is this representing?
V.
Volume. So I'm going to have a V for volume. So what is the symbols for what they tell me?
48.
What symbols?
Radius.
dV,
Over
dt.
dt.
So they've established the unit of length is feet and the unit of time is seconds. Yes? Let me stop for a minute. Do you guys start to see how V prime kind of sucks when there's more going on? If I'm just taking a derivative, freaking put Y prime. Who gives a shit? But when I have all these variables running around, I want to know. And then I got time, which is a background dude. He's not going to show up in any frickin' equation because he's a little jackass running around behind the scenes. Okay. So that is 48 pi. Believe it or not, I said it was 48 pi to be nice. Now this is an example. For some reason I didn't give this to you, and I think it was because, I think I already did this with you guys, but I wanted to point out that, when in doubt, look at the front and back of your math book. If you get a new math book and you don't look in the front and the back, I don't understand you. You want to know what the shit it gives you, and what answers does it give you? Not every math book gives you every odd answer. Some of them give you a weird selection of answers, so take a look first thing. So here's the volume of a cone. By the way, a cylinder is pi r squared h. If I chisel out a cone shape from it, I cut 2/3 of the shape away, and I'm left with 1/3 of the shape. Do you have to know that? No. But it is interesting, maybe. So now I put down here my relationship. What's wrong with this? Because what are they, now one thing I didn't do until later, well, I'm kind of stepping us through, that's a good point, okay. I'm stepping us through, I forgot what I'm doing here. There's not a full on your own problem. Okay, there's the cone. There's my water. There's my height. There's my radius. What's this? Right here is 20. And of course this is 60, so I can put that. Watch this. If I draw the height into the cone, what shapes did I just make? Triangle. Interesting. Interesting. We're about to talk about the most common geometrical thing that will happen in a related rates problem, which is similar triangles. Because what is wrong with this volume formula? How many variables are in it? 3. How many variables are we able to handle? 2. y equals a function of x, v equals a function of r, right? There's too many, the number of variables in this equation is too damn high. So, okay, sorry. Volume of water in the tank. Bam! I put that in the wrong place. All I wanted here was the draw and label the cone. If I would just read my own instructions, I'd do so much better. Volume formula is here. Can somebody help me out? How many right triangles do you see in this? Let me draw this like this. So there's 20, there's 60, there's R, and there's H. So yeah, there's 2, right? You guys follow? Do you guys remember similar triangles? A similar triangle just means that one triangle is a multiple of the other one, just blew up. So what relationship must hold then? Like, for example, here's a concrete example. 3, 4, 5 triangle. Look at him, he's a little cute dude. Look at him. Oh shit.
Not on the screen. Thank you.
If I double in size, if I double this guy in size, will this angle change?
No.
No, of course not. It's like me just putting the paper closer to my face. Oh my god, he's growing. Okay. So if I double him in size, what happens to every side? This was 3, now over here it's
9.
doubled in size.
6.
6. This is now 8. This is now 10. We get it now, boy. Okay. So there is some number that I multiply all sides by to create the new side. Yes? The new sides. Which means, what's true? So what did I multiply by? 2. Which means 6 divided by 3 is 2. Right? And then of course 10 divided by 5 is 2. So aren't these equal to each other? And you can even set up, equals 8 divided by 4. Proportions, yes? Proportions. So can somebody give me a proportion that relates R and H?
20 and R.
What about 20 and R? What about them?
3.
Whatever I multiplied R by, how would I figure out what that was? If I just gave you this picture and I said, hey, I multiplied every side by something, how would you figure out what I multiplied every side by? What would you figure out? How do you figure out what I multiplied every side by?
21 divided by
21
7.
divided by 7, yes? Okay. So, how would I figure out how I multiplied what I
60
multiplied?
divided by 20.
Okay. No, well, okay, sort of. 20 divided by R.
20 divided.
And that has to equal what? Since I multiplied every side by the same thing, what must 20 divided by R equal?
60.
60 divided by H. Now, there's a bunch of different ways you could do this, and hopefully this sounds at all vaguely familiar. You could do little to big like we just did. You could do height to base equals height to base. Let me write that down. You could do height to base equals height to base. Well, I keep saying height, and this is the way it's drawn. Very simple. Do you see how those are the same dumb things? What do you get when you cross multiply here? What do you get?
20 over
20 cross multiply. You can do it.
28
20H equals
over 60R.
60R. What do you get when you cross multiply here?
28.
20H equals
60R.
60R. Of course you get the same damn thing because both represent the same relationship. So are we now able to find a relationship between the radius and the height? In fact, did I already do that? Little overachiever math boy I am. What's the relationship between height and radius?
28.
Yeah, be better. What can we do with this?
Would it be the radius equals height over 3?
Yeah, looking ahead, I want in terms of the radius alone. So if I solve this for H, H equals, 60R divided by 20, so H equals 3R. Okay, let me stop for a minute. the H will have to be 3 times the R, because that's what the big triangle kind of set up. Its base was 3 times its height. Yes?
Didn't they say like pick a arbitrary height of water? So we know what H is, right?
Well, H is H.
Yeah, I mean, it's like you're gonna divide it. Oh, yeah, I can think. Right.
Arbitrary height, so I don't know exactly what it is. Yeah. Now, I'm hoping to God you guys have somewhere in your math careers have worked with similar triangles before. You've worked with proportions before. This is one of the most common things to happen in related rates, because right triangles show up a lot. There are a lot of shapes that have these 90 degrees built into them, so we often get right triangles. I'm not saying every damn problem is going to have a right triangle in it. I'm saying a lot of them will. Can we now take the volume formula? We write it down. And I want to write it in terms of radius only. I only want R to show up. So what letter do I want to get rid of? H. So I'm going to do it very subversively. Has anybody ever seen Invasion of the Body Snatchers? The movie. Several movies that have been made over the years. Basically, little hot people come and they take the place of people. Right? If you don't like horror movies, don't watch it. But I always think about this. We want to get rid of the H, so we're going to sneak in the middle of the night, and we're going to replace H with something that's equivalent to it. What is H equivalent to? 3R. So in the middle of the night, we're going to go here, we're going to take him, we're going to put 3R there. And nobody's going to know the difference because H is 3R. Right? We're going to lock H away in a closet somewhere. Okay. I've watched too many movies. So in place of H, since we know H is 3R, we can put a 3R. Can you simplify that for me? Yeah, what nice thing happens? The 3's cancel. The R's can be put together. So I get pi R cubed. So, do you see how this is immediately very different from the last problem we did? The last problem we did, they gave us the formula. It was great. We used it great. This one, the formula got too many variables. Shit, I gotta take a minute and figure out a relationship between two of the variables so I can get rid of one of them. In a very subversive way, just in the middle of the night, go replace it. Yes? Now, is my volume a function of radius only? Yes. It only cares what the radius currently is. So as it drains out, I can tell how quickly it's changing if I just know what the radius is. That's all I need. This will be infinitely easier to take the derivative of. To be really honest with you, you could take the derivative of this stupid thing. This is part of what we're going to talk about in a minute. That's a product, yes? You'd have to use product rule. Wouldn't that be much worse than taking this guy's derivative? Isn't this much preferred? Also, you're going to get dH dt and dr dt, and you're not going to necessarily know all of that shit. I don't know if you guys are with me or not. So now, here's the question. We've got the formula now. This is the formula for this specific situation. This specific tank, that's the volume, at any radius. So at what rate is the radius decreasing when the radius is 16 feet? So I'm going to bring back what we set up in the beginning. dV dt we noticed was 48 pi, yes? That's the value of dV dt. What in symbols, what are they asking me for? What are they asking me for in symbols? dr dt. I've got my volume formula, so what I'm going to do?
Take the
Yes,
derivative.
take the derivative so I can use my information and actually solve for what they want me to do.
3 pi r
I
squared.
got information and question about rates. I better take a derivative so I have rates. Go ahead. I'll wait. I was going to say, well, let me write this more in English, but I guess let me write this more in Greek. catch up to you. What do we get over here?
3 pi r
Three
squared
comes down. Times
times pi r
dr
dt.
dt. Good old chain rule. And now it can just plug and shove. So now it's really nice that it gave you this in terms of pi, because then the pi can just freaking die. Poor little pi dude. What's r? 16? What's 3 times 1/16? What's 3 times 16? I know there's 2 there, right? Which means I could do 3 times 16 is 48 times 16, yes? You guys see why I want to do that? 48 pi equals 48 pi times 16. Die. So what's dr dt?
1/16.
1/16 what?
Feet over second.
Yeah, feet per second. What was the radius at the top? 20. So at a time when the radius is 16, we've gone down to where the radius is 16. This is how quickly the radius is changing.
The lower the radius, the lower the height of the water changes.
Yeah, this one's alright. So this one's a little bit freaky because somehow we're keeping the volume drain constant.
Oh.
So maybe there's a spigot and I'm just kind of like closing it slowly, somehow keeping the volume of water coming in. Or yeah, let me think about it.
So it's a
Opening
valve.
it. Because at first it's going to be draining based on the weight of the whole water. Anyway, so it's kind of reverse of what I said earlier because I was just trying to keep it simple, the physical reality. It's a little bit
It's a controlled valve.
control valve, controlling the flow of water. Yes. So this is going to happen. You've done this before. I really hope. Systems of equations. We have one piece of information you can plug it in. Substitution method. Elimination method, substitution method. Does that sound at all familiar? That's all we did here. We had one equation, and we used it in another one. So now I've got one variable instead of 2. I can take a much more direct derivative, throw in what I know, solve for what I don't. Okay. So let's do this. I want to kind of, unless there's follow-up questions to this, I'm going to transition into review. And something that came up last time that I wanted to focus on was, when is a product, when is it change? Yes? So, what I want you to do is notice the instructions on this before you guys just start doing all kinds of stuff.
X times 3x product.
Want each of you to work on this by yourself. And then I'm going to have you compare answers with people near you. Guys, a sense of...
Frustration?
Well, maybe a little bit. I think the most evil problem on here is potentially 1A. 1F could be, but I mean, alright, not really. 1A Who believes that's product? Anybody?
I did.
All right. And 1A, who believes that's chain? All right.
It's chain.
All right. I like the product people were confident in their answer, and the chain was not, which is good because chain's not right. It's a product. If I intended this whole thing to be inside the ln, what would I have had to put?
A parenthesis.
Yes. So what is the only thing inside of ln? X. So it's ln x times other shit product. You with me? Think. Some might disagree, but it's not as bad. What about 1b? It's basically the same shit,
Product.
except what's true now.
You have the subtraction.
Yeah. Do you guys see that as not natural log times? That makes no sense. That's like reading this as the square root times x. Yes? And it says solve this, and you're like, all right, divide by the square root symbol. There we go. No, that's bullshit. Okay. Too far, Jeff. You've gone too far. This has stuff inside of a natural log. Nothing else is going on. That's immediately chain. So this is product, this is chain. Working on the, sorry. What about part C? It is a
Chain.
part of part D. Part C is very, very obviously, hopefully, chain. It's stuff inside of something else, right? So if I take the derivative of this, I will use chain, yes? Then I'm about to say something that I really hope makes sense. Well, everything I say I hope makes sense, but this is crucial. If I took the derivative of 9x cubed minus 5x all to the 7th, that is chain. Am I taken on part D is the question, take the derivative of 9x cubed minus 5x to the 7th. Is that the question? No. It's taking the derivative of this whole damn thing, yes? Now, I know I said don't do a derivative.
Product.
What did you guys say for this one?
Product.
It is primarily product. Primary product. Sorry, should have said there was
Because
a
it's divided.
splash zone up here.
I mean,
Because it's one function times another function. Now, if I did product rule, and I know I said you didn't have to, but I'm going to do it because I'm the teacher. I can do whatever I want to. Wouldn't I take the derivative of the first guy? Jeff, you can't see anything because your eyes need help. Okay. Wouldn't I take the derivative of that times this, plus this times the derivative? Right? Now, in that very first, is everybody cool? That's product rule. That's what you should do if you're going to be nice to yourself. If you're like, man, this is really mean. This math is mean. Well, then be nice to yourself. You got control over that shit. Write the rule. Don't do any derivatives. What's the very first derivative I have to do? The same one. And now I do chain rule because the function I am currently taking the derivative of has shit inside of something else. Yes? Do you guys see what I mean by this is primarily a product rule? When I take derivatives of each piece, then chain rule comes into play. You don't even have to know that at first. You just got one function times another function, product. When I do those derivatives, oh, it's a chain rule. I see it. You don't have to know everything ahead of time. Holy shit. Good mate. I guess, how do we do? What's the difference between E and F? What's E?
Chain.
Stuff inside cosine.
This is one that drives me crazy.
Stuff inside.
If somebody, first step on your homework, you write this, and then you start doing something. Where did X come from? This is sign of stuff. That is definitely chain. That is stuff inside of a function, right? And what is this?
That's product.
That is product. That's sine X times this shit. Is that better? Is that better? Because I heard a lot of you guys kind of saying something similar about when is a product, when is a chain. It could have both, but the first thing you think about is just what is immediate. Is it made of the product of two functions? Well, then product. Well, is it primarily something shoved into another one? Well, then chain. There could be product later, there could be chain later. All you care about is what's first. I need you, and if I see what's first, I then have made simpler problems for me to do next. This is a simpler problem. Chain, bam. That's a simpler problem. Chain, bam, right? Maybe. I made two little problems on the ends that are each simpler than the original ones. And then I can attack those. That's what applying the rule does. Don't do that. I'm not saying I'm gonna take points off if you do. You can take the derivative first step. But if there's a lot going on, I would write the rule, then I would focus on derivatives, because our brains tend to put things together wrong. If I'm trying to do it in my head, show myself what the hell I'm doing. Yes? Okay, maybe. You suck, Jeff. Good try, Matt boy. Okay. All right. Now, I don't want to take up more time. I'm sorry. I want to open it wide up to whatever you guys want to focus on. I've got the answer key for the practice test. I will give that to you later. If you have to leave, make sure to grab one before you go, yes?
When is product rule plus or minus?
Let's do it again.
When is product rule plus or minus? You guys said stuff plus the other stuff?
It's what is product rule always got in the middle of it? Plus, always. What has a minus in the middle of it? Quotient. Can somebody recall why that minus is there? Because the song says, Payula minus Payula, that's what it says, or is it the other way? Why is there, does anybody remember why there's a minus there? Because you're taking, on the second part, you're doing G prime, and where was G? On the bottom, so it'd be to a negative one power. Of course it's gonna be negative, because it was on the bottom, it's got a negative one power. You guys see what I'm saying? Now listen, that's the way I looked at it. Because I have hated mnemonic devices in songs. I have, don't get me wrong, I love songs. But not when they make it seem as if it's so hard I couldn't get it otherwise without the song. I think we're doing a disservice to students when we teach you all these songs. You're like, well, thank God he taught me this song, I wouldn't know. No, you know how to do it. You made it. So we all know in quotient is a minus because that's the one I'm doing the derivative of the bottom, and that's why the derivative of the top was first. Because it would be the positive part. Does that make sense? Now, if you know the song, does anyone know the song? I started singing it just a second ago. That brings to you, if you don't know it, just keep it like that. You're awesome. It's like, if anybody doesn't know Sokotoa, you're ahead of the game. Okay. Well, if you don't know Sokotoa because you don't know Trig, you're in a whole other thing. All right, I'm sorry. So, we could do any of these derivatives you want to. We could do something off the practice test. We could look at the quiz you just got back. If I'm just up here spouting shit that you know already, you could work on your quiz corrections and ask questions about that. You guys kind of with me? What's due Wednesday? Homework through what?
Test correct.
Homework through what? 3.9. The other section, 310, will be on the next test. What's up with 311?
Extra
Extra
credit.
credit.
What is that?
Day of the final. Yeah, sorry, thank you for saying that. So in web assignment, I remember assigning and give you the day of the final due date. What else is due to Wednesday?
Test correct.
Test correction, test one corrections. This is your first test one. This is your first test due date, right? Test corrections for test one. And quiz 2, quiz 3 corrections, yes? Yeah, kick ass. That's all.
Good, that's it.
Now, if you have trouble finishing any of that, just let me know. Right? Try to get as much done as you can, because every single thing you do will help you for this test. Why do I make test corrections do? Because you have to, all of that builds into what we're doing here, right?
Practice.
So, it's wide open. We can talk about anything specific, general, yes?
I have a question on my test. The first.
Oh, okay. Give me after. Sorry. Who else? It's a little too specific for you. Sorry. Yes?
Number 47 from 3.5 homework.
Oh, yeah. Okay.
So I found the derivative, but once I have that, I'm equaling it to 0. Am I solving for y or x?
Here's the neat thing. Okay. How do I say this, generally? You set it equal to 0. You solve for whichever letter you can solve for. Now, real quick. If I set a derivative equal to 0 and I got x equals 2, how do I figure out what y is? For example, plug it into the original function, yes? So if you could solve when you set it equal to 0, can you solve for one of the letters? Or can you get a relationship between the letters?
Well, this is the original one.
Oh,
I
cool.
factored it out.
Yes. Set the top equal to 0.
Okay.
And then you get a relationship. You get x squared plus y squared equals 25/4. And you're trying to do a little too much here. Oh yeah, you can't do this. That's for sure. Square roots can't distribute. Okay. Yeah, that one's a little bit trippy. I might go over it later. It's a little more of a challenge problem than a meat and bones problem, like a nuts and bolts. So we'll talk about it later if you remind me when we get to the end. Ezekiel, did you have a question?
Oh, yes, I actually was gonna ask about, the, like, you mentioned that, and, it was kind of hoping we could, like, I remember I was working on them earlier. And, yeah. I was trying to figure out how, I was trying to figure out, I think, oh yeah, G, yeah, 3D.
On the practice test?
No, on the, like, the first episode.
Oh, the first test we took.
Yeah.
Oh, all right.
Yeah, making the definition.
What was that one about?
It was basically asking why, the graph was just coming with an x equals 4.
Oh, okay.
I was thinking, yeah, just.
Also, that's the idea. Yeah, it's a little too specific right now. So where do you want to go? You got homework questions. Remember, this test is 3-1 through 3-9. Right? So it's basically all the methods of differentiation. If
I have another one on 25 and
Yes.
67.
Oh, it's also easier, harder.
oh yeah, okay. God, I love you guys. All right. A lamp is located 3 units to the right, and the shadow created by elliptical region. Yeah, okay. X squared plus 4y squared less than equal to 5. Okay. So you got this shadow, right? Kind of reminds me of the umbra and the penumbra and an eclipse. If the point -5, 0 is on the edge of the shadow, how far above the x-axis is the length of? Ooh, I like it. That kicks so much ass. Do you see how there are slopes involved here? Do you see that? Could you figure out the derivative of the slope at any point on this? Can you figure out the slope of any point on this? How would you do that?
They give you the equation of the.
They give me the equation, so I would just take the derivative, yes? Then you know the slope at any point, yes? You also know what point is this. Because it's asking how far above the x-axis. So let me see if you guys, all right. Whenever I answer a question like this, if I have seen this, I try to pretend like I haven't for a long time. This problem I haven't done in a while. Very first thing I noticed is there are slopes involved here, which is good to look for because this is calculus. And the most important thing on the first couple tests is derivative, and that's slope, correct? What's this point?
The x is 3, but.
3? Y, sure, 3y. Is that cool? What's this point?
-5x.
-5, 0, yes? Could you figure out the slope between those 2 points? Do you see what I'm
Yes.
saying? You have a slope from this, you have a slope from this. I don't know. That should be maybe enough to get you going, okay. That kind of thing happens so often where we want to try to take the slope from a curve, okay, I can do calculus, and make it equal to the slope of something else. Okay, set those equal to each other, right? But the first level of this was to notice, hey, I see freaking straight lines. That's slope. I know a point, and I know
half of the other point. Maybe that'll get me somewhere. I don't know.
So since you just wanna see, because of the question, it's just kind of, you wanna see the height of the lamb,
Yes.
you don't really focus on the others.
I'm trying to solve for why. So why did I pick the points I did? Why am I not curious about the other side? Because it's the only side they give me information about. Okay, maybe. Meh, we'll see. That might be enough to get going. I'm not telling you that I just told you one more step and you're done. I told you at the beginning.
That makes sense.
Okay. And again, real quick, if the only problem you have trouble with like number 67, you're doing beautiful. Number 67 is what I would call like a homework bonus question. You still got to do it. You still got to try it. But if it's the only one you had trouble with, or one of the few, you're doing amazing. That's trippy. 67 is trippy. I want to be very open about that. Because as a student, you're like, am I supposed to know this immediately? No, you're not. No, it's trippy. Yes. 57 in the same section? Yeah. Okay. $57. Oh yeah, this is really good. This is one that the tutors are always so happy when they assign this problem. All right, this one sort of has the same beginning, but real quick, orthogonal trajectories. All that means is one and the other one are perpendicular to each other. You guys know how perpendicular slopes interact? Do you guys know that Google is, they do talk about orthogonal trajectories, but you have to kind of hunt it down. I can't remember if it's in an example or in one of the earlier homework problems. Orthogonal, I think I told you guys, didn't I tell you that perpendicular has a lot of different words we use for it? We call it orthonormal, orthogonal, perpendicular. It's like, come on, pick somebody. That just means the two are perpendicular. What's true about two perpendicular slopes? If this slope is 1/3, -3, yes? You guys with me? Now from your perspective, that's backwards, I'm sorry. It worked for me. So it's gotta be the negative reciprocal, yes? Are there derivatives you can do? Yes, okay. This one is extra. I mean, it would take quite a bit. So I at least want you to get started on it, and if somebody gets the complete thing, like clean, no erasure marks, I'm a little worried you got it from somewhere else. This should be one where you're like, oh shit, I'm not sure, okay. Because it's trippy, it's just trippy. I don't know if you guys understand. I have to give you some like this. Because this builds on what we're doing. Alright, that's as much as I'll say. But again, if this is like one of the few you have left to do and you have no idea, try something. You at least do derivatives of these, yes? Does everybody understand derivatives of these have to come into play? Because orthogonal is all about how the slopes react, yes? At least do that. And maybe try to do something else. You're like, I have no idea where this is supposed to go. Fine. Because this is trippy. Yes?
I guess you already answered it, but can you give us like a start of what to do after we find implicit differentiation?
So think about, for this
For
one,
this
right?
one, yeah.
Think about, so orthogonal trajectories mean the two slopes have to be negative reciprocals of each other, right? So try to force that relationship, try to set them equal, see where it goes. There's a little more you have to do at the end, and this is the part that tutors have trouble with because they tell me this. Okay, but again, don't like spend all your time with this stuff. Give it a try to see, if you can't see where it's going, let it go. But I want to see some attempt.
Equal it to each other, but
Yes, there you go. Through using the relationship they're supposed to have, you can force them to have that relationship and see what that leads to. Okay. Very often, if you get that and you do that and you sort of work with it and you start to see things, it'll tell you what to do next. But does anyone have questions from like a more nuts and bolts question, or is everybody only having trouble with those problems? If everybody's only having trouble with stuff like 57, you're all doing amazing. The bursting was bubble, but I'm almost certain I can't trust that. I know some of us have trouble with some of the other problems, yes?
there's something from 52, I was looking at the exponent.
Which
Same
one?
section. Same section, 52.
52.
this one's cool. This one's not too crazy, but it's a little crazy. Yeah, so it's like a proof of the power rule for rational numbers. And that's something that I sort of glossed over. And one reason I did that is because I knew I was going to assign this. So I was going to have you guys prove that it works for rational numbers. I don't know if anyone remembers how we developed the x to the n rule. We used Pascal's triangle. X plus 1 squared, x plus 1 cubed. Does x plus 1 to the 1/2 fit in Pascal's triangle? No, it doesn't. But nobody said shit about it. So I'm like, all right, cool. We just keep going. I did not prove to you that it works with fractions. I just kind of said, yeah, it works with fractions. Because I knew I was going to sign this one. Now we know enough. We actually know enough now to go back. So does everybody understand what happened from here to here? This is just, so x to the n, sweet. X to the p over q is just being more specific. Oh, it's a fraction up there. Yes? Real quick, if I had 2 equals x to the 1/3, how would I solve for x? 2 equals x to the 1/3. What would I do to both sides? 2 equals x to the 1/3. It currently is the cube root, so what would I do to both sides? Raise it to the 3rd power. So do you see if I raise both sides to the q power? P over q times q is p, and of course that will be q. That's all they did from that to that. Is something happening to the y now, the way we've got it written? Is something happening to the y? Is something being done to the y? Yes, that means it's implicit. That's the point of this problem, is now that we know implicit differentiation, we can actually go back and investigate some freakier shit. One of them is this thing we just sort of assumed was good. And you all assumed it. I don't blame you, but you should kind of be like, why did I just say it was good? I should have been like, hey, why does it work for fractions? All right? But it's okay if you didn't. It's not your fault. So that's why they say use implicit differentiation. Now you want to implicitly differentiate both sides of this. Real quick, what is p? Is it a variable? No, it's a number, right? And what is q? Number. I think I was pointing at q and saying p. I'm sorry. You guys kind of think? So now I know each of these is just variable to a number. That's the power rule on both sides. What is the derivative of y to the q? Yeah, q comes down. Power goes down by 1 times y prime. And now do the derivative of that side, solve for y prime. Maybe. By the way, how do you take the derivative of x to the p over q? Just if I do it directly, just assuming that the rule works the way it's supposed to. How do I do that derivative? The power comes down. P over q minus 1. Yes? Yeah. That is what you're hoping you get for dy dx at the end. Because that's what the hell it's supposed to be. Yeah? Okay, maybe. But this is a proof using implicit, which obviously we couldn't do when we first talked about this. Okay. Okay, maybe. Again, 52 is trippy, but it's nowhere near as trippy as the other ones. Okay. So let me ask a question. Hey Jeff, when do you do that weird shit, the natural log shit? When do you have to put a natural log in? You guys remember doing that? Do you have to take a natural log sometimes? Can somebody tell me when I have to do that? Or when I can? There's a situation where I can do that, and there's a situation where I have to do that.
Is a variable in the power?
Yes, I love it. When there's a variable, not just in the power, but when there's a variable in the base and the power. So if I have something like this, oh my God, I zoomed way the hell in. And I want to take this guy's derivative, I have to use a natural log to help me out. The trade-off is I'm going to have to do implicit
because now I'm gonna do something to my y. I'm gonna take a natural log of it, so I need to do implicit differentiation. But it makes it possible to do. What the shit rule would I use on this just directly? Do you have a rule for sine x to a power? Especially not a variable power. So it's a variable function base and a variable power. We don't have a rule for that. So what would I do? First step is I bring y back. What's going to make this not a power anymore if I do what to both sides? Natural log. That is now able to come down because it's a property of natural logs. Chain, product, yeah, implicit, yes? Maybe. What's the derivative of ln y? What's the derivative of ln of anything?
Y prime over y.
Well, the derivative of ln stuff is 1 over stuff, yes? And of course, what's the inside? A function of x, so I have to do y prime, yes? What rule did I say this was? Do you agree with me? It is a product. Will it have a chain? Yeah. Do I have to even know that right now? No. So it's derivative of the first times the second, plus the first times the derivative of the second. I'm probably running off everything, aren't I? Zoom out, Jeff. Derivative of the first times the second, plus the first times the derivative of the second. If you just do this for yourself, you will stop making certain mistakes. I didn't do any derivatives on this side. So here I get y prime over y, like Paola said I should write it, and I agree. Derivative of x is 1 plus x times, what's the derivative of ln of stuff? No, derivative of ln of stuff is?
Oh, 1 over.
1 over stuff times? Derivative of stuff. What's the derivative of sine?
Cosine.
Cosine. Okay. Right? So you multiply by y. Y was this shit here, right? Times ln of sine x plus, what is cosine over sine? Cotangent. There, done. By the way, that poor little guy is in there. Why does this part make, let me see if I can get anybody to be with me on this. What's the derivative of 7 to the x? 7 to the x times natural log 7. What's the derivative of 28 to the x? 28 to the x times natural log of 28, right? So what's the derivative of sine x to the x? Doesn't it make sense its derivative should have it in there again? Because that's the fundamental idea of anything to the x. Y's got a lot of other shit because this isn't just number to the x. This is function of x to the x, so it's going to be more complicated. But the fact that it has itself in it makes nothing but sense, because everything to an x has itself in it. E to the x is the best. Such a good guy. Right? Derivative of e to the x is e to the x. You can't teach. For a moment, I thought you meant conceptually, but you meant literally, physically. Okay. When are you able to use logs if you want to? Let's do a problem like that. And then I'll stop and see if anybody else has specific questions. I'll stop asking us questions. This is an example of a problem where you have to use a natural log. Or some other log if you don't like natural log. Here's an example of somewhere you can use a log to help you. What rule would you use if you just had to attack this directly?
Close.
Well, oh, okay. Well,
Rewrite.
How can you simplify it?
Well, technically, I mean, the lack of supervision.
Rewrite.
Technically, we're
Yeah, I see what you mean.
You
Sure.
could rewrite it.
Yeah, you could do that.
Could just use
And then it would be like a bunch of
product machine.
product. Yeah. Okay. Yep. It would still be kind of a 3-part product rule, correct?
Still better than quotient.
Yeah, I agree. Still better than quotient rule. I agree. Or if you take the natural log of both sides, this would be ln of x plus 2 ln of x plus 1 minus 1/2 ln of 3x squared plus 1. When you multiply, you add, the 2 can come down. When you divide, you subtract, the 1/2 can come down. And now each one of these, what did I write there? Each one of these is relatively easy, right? I'm not a big fan. I would be with Ezekiel. I actually am not a big fan. That's why I said you can use logs here. Probably I wouldn't, because it really, each little derivative is easier, but the result's going to be gross. Because what am I going to get for the derivative of ln y? Y prime over y, I got to multiply y. So I get the entire y just sitting there again staring at me, and I feel kind of like, I did nothing. What have I done?
Yeah, you are prime divided by y, so you have to take the original y and then divide it by 3y up there. And yes, technically it's accurate, but it looks
Looks, yeah, looks worse than it has to, yeah. Yeah. Okay. While I'm thinking about it, this is, I just realized something I never really told you guys. Remind me, what's the derivative of ln of absolute value of x? What's the derivative of ln of x? 1 over x. So the derivative of ln of absolute value of x is 1 over x. Remember I told you the fuller story to match the domains? What's the domain of this? Everything except 0. If I put the absolute values, the domain of this is everything except 0. Without the absolute values, the domain is 0, parentheses 0 to infinity, correct? If I put absolute values, these match. So this is the more full picture of the definition of the derivative of ln. This gives me an absolute value and it doesn't change. Something, before I go to what I'm about to, what's the derivative of ln of 3x? How would I do that? What rule would that need?
3 over 3x.
What's the derivative of ln of stuff?
3 ln.
Times derivative of stuff. What do the 3's do? Do you see how you get the same stupid derivative? Why is that? Because what is the natural log of 3x? Isn't that the natural log of 3 plus the natural log of x? So if it takes this guy's derivative, what's this part? What's the derivative of ln 3? 0, because it's a stupid constant. So any constant multiple of x inside of ln, the derivative is still 1 over x. It don't give a shit, because that ends up being just a shift. It doesn't change the slope. It just shifts it up or down. That's a little bit trippy. Now, the real thing I want to show you. Can somebody remind me what the derivative of 7 to the x is? We said this earlier.
7.
ln 7, John. What is the derivative of log base 7 of x? Okay. It's going to be 1 over x, just like ln would be, because log 7 is just another log, like ln is just another log, correct? Do you guys see, though, that ln is what base? E. When I take a derivative with this function, I multiply by ln of base. When I take a derivative of the inverse function, I divide by ln of base. Because they're inverse functions. That kind of makes sense. So why does natural log not have that piece? Because what's the base for ln? E, and ln of e is 1. Okay. Maybe. Screw you, Jeff. I can't remember if that came up in homework. It probably did. And then you just look at the rule in the book. Not that big of a deal. But the fact that they're inverse functions, it makes sense. One multiplies by ln base. The other one divides by ln base. Okay. Oh, let me leave that up there. Anything else you guys want to look at? It's wide open. Anything from the practice test? Anything from the quizzes yet?
Well, I'm still kind of like focusing on that.
before we learned any shortcuts. That was from chapter 2. So we only knew that limit is h equals to 0 thing. Oh?
Sorry, what was that?
Well, what's f of x?
4x squared minus
So f of x plus h, you shove an x plus h in. F of 3, you would shove a 3 in.
yeah, sorry, you just added h.
No. So if f of x is, just to make something up that you don't have, this, yes?
Right?
What's f of 2? 4 times 2 minus 7 times 2 squared, yes?
Yeah.
You shove a 2 into it. So what's f of x plus h? You shove an x plus h into it. How do functions always work? They're just substitution. At the most foundational part, whatever you put into them, you put into them. If I put an x plus h into f, I put an x plus h into f. I replace x with x plus h. Now you distribute, you FOIL, right? Do the same thing with yours, yeah. Just so you guys know, he's doing the limit definition problem from the first test, yeah. That's why we're talking about this stuff again. Okay. I'm sorry. Did you have? Yes.
I was just gonna ask, in 3.7, question 3E. So for me, I found that the velocity was 0, but how do you figure out what the total distance is if everywhere the velocity is 0? But then also with the position function, it's just one thing, you can't plug anything
Here.
in.
This. This is a great little. So what this says is, like for example, at time 1, velocity went negative, which means he's going back home. So all this distance they gained, they lost. And then at t equals 3, it turns again. Do you see what I mean? So if you figure out what the position is at t equals 1, there's a few ways to do this. You could actually read through the way they did it. You can look at the position when t equals 3, yes? And then you'll know how actually far you went, which is not very far. And actually the position is 0 again, you went back home. So then the entire distance just cares about how far this is. However far this is, I don't know, do they say, I don't know. I don't know if that makes any sense. So that's why you have to figure out when is your velocity change signs. That tells you when you start to go back. So then you're losing distance. And then you look for a change sign, oh, now I'm going away again.
I understand that, but with 3, it's asking f of t equals sine of pi over 2, but you can't plug anything in, so wouldn't it just be a constant line? Or how do you figure out what s of
This is pi t over 2, yeah?
Oh, there's a t up.
There is, okay.
Then I just wrote it wrong.
No worries. That would be awesome. If your particle's just sitting there, you're like, oh, you're the best thing in the universe, particle. Because then everything is 0. Yes?
On the practice test,
Let's see. Do I have any left for myself? Yes. Oh, this dude. This dude? Yep, okay. Do you even know what the letter that is? What'd you call me? Yeah, that's sorry. There's the wolf study that led to alphabet is a bunch of shit, just so you know. So if you think you're an alpha, you're stupid. So alpha beta, what primarily rule am I going to use? What rule is it? It's primarily chain, yes? It's the square root of stuff. It's not the square root of stuff times anything, so it's not product, it's chain. And how should I rewrite this first thing? The square root, roots aren't good. We don't have a rule for a root. We have a rule for powers. Cosecant of stuff, all to the 1/2 power. So then when you start the derivative, what's the first step?
Bring out that 1/2.
Bring out your derivative. Take the 1/2 down.
There we go.
Jeff.
The stuff
Stuff times
the derivative of
I don't want to write it. Stuff, yes. Is that okay for the first step? Notice how this does not change. How do you take the derivative of something to the 1/2? The 1/2 comes down in front of something to the 1 less power, yes? That something does not change. You don't take a derivative of it at the same time, because we all know every rule is everybody gets its own turn. Times now the inside stuff, all this shit inside gets a turn. Now this does involve 2 levels of chain rule, 1 level, 2nd level, but do you have to know that ahead of time? No. You don't have to know that shit ahead of time.
Sorry, I'm a little bit confused. How do, like, I can't tell that, is that a pi? Like, is that an 8? I can tell that's like a second part. I can't tell that's.
I don't know, I don't see any notes, I got 5.
It's just the original symbol.
Oh, here? I started to put CO, because in my head I was thinking cosecant.
Like, the second on the right.
Here?
Yeah, to figure out what that is.
Stuff.
Oh, like.
I didn't want to write stuff, I could,
Oh,
but I'm
you
just,
meant
I'm
like-
just lazy.
Oh, you meant everything today.
Yeah, I meant the inside stuff, yeah. That's why I drew a line. So this would technically be, because all it's missing from my classes is me writing more. Let's see. God, I keep wanting to write that as CO. Yes, so the stuff that was inside of radical gets a term. When I take this guy's derivative, it's derivative of cosecant of stuff, and then the stuff gets a term, yes? And again, I don't know. Some of my colleagues teach in such a way that you actually have to know ahead of time how many chain rules, and personally I think that's insane. All respect to my colleagues, but that's insane. I just worry about them when I'm like, okay, now this stuff has stuff inside of it. Okay, another chain rule. I don't have to know ahead of time. I see now. Oh, there's another chain rule. Yeah? Okay. Yes?
So that'd be cosecant, cotangent.
Yes, well, one little thing's missing. What's the root of cosecant?
Negative.
Negative. Cosecant, cotangent. All the co shit's negative, right? Cosine's negative sine, cotangent's negative cosecant squared.
And then you take the derivative
Of the inside, yeah. So real quick, that's a really good question there, Michael. Alright, so all this crap, blah, blah, blah. Let's focus on this guy. What's the derivative of cosecant stuff? Negative cosecant?
Cotangent.
No. Negative cosecant stuff times cotangent stuff. It
Okay.
doesn't make sense any other way. Times the derivative of stuff. I'm going to zoom out again. Derivative of cosecant of stuff is negative cosecant stuff, cotangent stuff.
Times 8.
Because the derivative of cosecant x is negative cosecant x, cotangent x. So if I replace x with other stuff, I got to replace x with other stuff. Yes? Okay. That's a really easy mistake to make. Tangent and, secant and cosecant are the absolute worst in the trig functions, I think. Because their derivative has them in it and something else. You know, secant is secant tangent. Like, what the hell kind of magic is that? Yes.
Would you, or can you explain number 4, the practice test?
Oh, that's the one I can't. No, I'm joking. All right. Number 4, I just wanted to make sure you guys could use your graphing calculator. You could actually do the math on this to get the answers to double check, but in your graphing calculator, graph that. So watch this. Graph this thing. I can see where it's increasing, decreasing. Okay. What do I need to figure out? I mean, it's kind of obvious where it first stops increasing.
That's 0.
0. It's kind of obvious where it secondly stops decreasing, yes?
Negative.
Okay. For a general function though, I might have to find the max and the min Do you all agree that the max and the min are the places where it stops doing one thing and starts doing the other thing? That's why they're maxes and mins. This one's kind of nice though. It gave us a nice one. You could do the algebra and kind of double check it. You guys kind of with me? Okay. But if I needed to figure out the min on my own, I could do calc minimum, left bound, right bound, guess. And then it's trying to tell me to, poor little calculator. It's not as good as those humans at certain things. How would you figure out that point on your own? Just by hand. That's the point where what happens? Where the slope is zero. So you take the slope set equal to zero. Right? Take the derivative. Yes. Set it equal to zero. So that you can do that by hand, easy. And you'll be better than the calculator. Look at the dumb calculator. This is 2.00013. No calculator's two. Now, calculator's bounded by its technological capabilities, and the algorithm it runs on gives up within a certain tolerance. So it kind of was like, it's close. It's good enough for good. Okay. Close is only good. Horseshoes, hand grenades, and calculators. Yes.
And then would the derivative of that function look like a
Say again. Oh yeah. So we know that for a few reasons, right? But I know just there would be x squared, highest power. But you also would know it's positive, then it's negative, then it's positive, right? So it's going to be very much a parabolic. Because I told you to sketch a graph of derivative. Yeah. If you figure out where it's increasing and decreasing, to do that you have to figure out where it's turning. Okay, maybe. Okay. So number 4 is basically me saying I didn't want to give you a graph like I did before, and say sketch the graph on top, right? In fact, now that I'm thinking about it, 4 really shouldn't be on this test. I think the semester I made this practice test, we didn't make it to 2.8. This is a 2.8 question, right? Okay. But it's more like a graphing calculator usage question. I can't remember now. What did I put on the? This is number who? 4? Yeah. Oh, I did. I put a repeat from test 1. Okay. Let me give you the answer key. Might as well. Bum, bum, bum. So everybody gets 2 pieces of paper. Don't get one of yours away. Those. Oh no, it's the worst thing in the world. I'm sorry. It is my handwriting. It's very exciting.
Thank you.
You're welcome. My good night.
Oh, should not look at this.
Everybody get one?
Yes,
Yes. Okay. Holy shit. Scared myself. So just like before, if you did not try the practice test out at all, maybe don't look at this, right?
Remember that? The old, yeah. That's what I would have done, yeah. You'll build false confidence, not what you want. Yes? Yeah. How many of you guys have recently gone to the Sissel for the first time? Anybody? How was it? That was good? Just remind you guys, there are different instructors throughout the day. At the front of the room, there's actually a schedule of when certain instructors are in there. I told you guys last time, I think, maybe it wasn't you, no, it was another class, shoot. If you're planning on taking 280 next semester, you can actually see if anybody's in the Sissel who's teaching 280 next semester. And then you can actually go in and see what they're like. You see what I'm saying? That's a bonus of the Sissel that we didn't even think about. So as a student, you can kind of shop. Go in there one day, this guy's all right. Go in the next day, this guy sucks. He's almost as bad as Jeff. And then go somewhere else. Right, so you can get a feel for the teacher before you sign up for the course. It's not a bad idea. Plus, just get help. Yes. Just to remind you guys, somebody already did this. Well, actually, not to remind you, but just in case you didn't know this, if you go to the Sissel, they have videos in the Canvas shell for when you sign up for the Math 099. You can actually review, and you can do a little practice test in there, and then you can do what they call an exit slip. Some of you guys have done that, and if you get it checked and they're all right, you can give it to me, and I'll give you bonus credit for that. Not like a lot, but some. Yes? What I normally do with that kind of thing is at the end, if you're really close to the next grade, that could go into telling me if I want to push you over from like a C plus to a B minus or something. You guys kind of. If you did some of that, that might push you over. If you didn't, you're not going to get pushed over. Yes.
So the bonus slip is like extra questions?
It's like a little quick, almost like as if it was a quiz,
Okay.
right? But you can get help with it and so forth. And if they check it off and it's all right, they'll stamp it, they'll sign it, and then you give it to me.
How many of those can we give you?
There's like 20 something of them.
Oh.
Yeah.
I thought you just took attendance, was what you were saying.
No, just like in the tutoring center, if you go in and never do a exit slip, or like, then I will still count the fact that you were in there. Yeah, so you can still just go there for help. Because you might need help with something that's not on one of those sheets.
Right.
And that would be really mean if I didn't give you credit for that. Yeah. So if you are going and you're logging in when you go, at the end of the semester I can see who went, how long, yes. Which is one reason why we use the system that we do. Yeah. So make sure you're getting credit for that if you're going. Make sure that you're logging in, logging out.
You have to log out?
Yeah.
Well, they
No, normally they'll catch you when you go if there's somebody at the desk.
Oh,
Or if you
literally
sign
didn't
out,
tell me
you-
at all.
Okay.
Literally just walk
You're
in.
good. Don't worry about it. If you logged in, you're fine. It might just say you were there for 10 hours. And
That's how
I don't think it's
I've been there for 5 years and
Yeah.
30 years.
He's still there right now. Somebody go get him out of there. Where is he? He's under the desk. If you're ready for the test, you can head out. I love how you're looking at me. You're all packed up. You're just like. But if anybody has questions, keep asking. If you guys just want to work on some stuff, that's fine. And ask me if you want to work on quiz corrections, get those knocked out. They're due Wednesday anyway. Yeah. 1H.
So I don't know if there's another way other than just push and move.
Oh, this guy.
Yeah.
Yeah. All right. So you always look to see if you can simplify something. With rational functions, you don't look to see can you factor something. No. With trig, you look to see if, like, fundamentally, is there a squared trig? Maybe an identity would help. None of this trig is squared.
So it's just quotient.
You gotta just use quotient.
It's really one, really thin.
It's a little bit tricky. Yeah. I can't remember how it came out. How did it come out? Oh yeah, that's the one I almost had to turn the paper. Yeah. There is, when you do the derivative, you do get an identity that if it was a test problem and you didn't notice it, I wouldn't take points off, I just put a note. But whenever you see cosine squared and sine squared, like, wait a minute, can these guys go together? Could I take their coefficient out so it becomes 1? Yes, that happens on that problem. Which is one reason why I get it. By the way, I just want to say, I really appreciate the work
that I see a lot of you putting into this class. And I always want your grade to reflect the work you're doing. And if it isn't, I keep making these pleas about setting up time with me, going to your peer tutors in the Math Science Center, going to the CISL. And to be really clear, you don't only go to the CISL. You can go to the freaking normal Math Science Center too. You don't have to go to the CISL if you're a calculus student. If you want to talk to another student who's a tutor, you can go in there. This is no problem. You guys with me? Especially since the CISL's not even open on Friday and we close at 4:30, right? You can go to the Math Science Center otherwise. Yeah, and like I said before, if you think you're doing everything you should be and you're still not doing as well as you want to be, talk to me. We can investigate things. Yes? It could be a prerequisite skill issue. It could be not having enough time to do enough homework to really get to practice. It could be anything. I don't know. So we have to sit down and take a look. Yeah? Okay. Everything I do is trying to get you what you need to pass. Sometimes I trick you into doing the things you have to do to pass. I don't have to trick you, you can just be very direct. Oh,
Thank you.
Yeah.
Okay, so the particle is moving in one direction. My answer to you would just be positive or negative.
No. That's when the velocity is 0.
No, the one the velocity is, oh, no, you're right.
That's when the velocity is 0, right?
Yeah.
So this question is, when is the velocity positive? When is the velocity positive? No. When it's positive or negative 3, what's the velocity? 0.
Zero.
Yeah, I can't be positive. When is the velocity positive? So the neat thing you can do is you can make like a number line right here. Now put negative 3 and 3. Okay, what do you get when you put a 0 in?
I didn't use 3.
No, what do you get when you put a 0 in? You can 81 minus 0 divided by 9 squared, you get 1, you get positive. So it's positive in here, right? It's 0 here and here, you with me?
Right.
It's positive in here. What do you get when you plug a 5 in? 81 minus 9 times 25 is negative. And the bottom is always positive. So that's negative there. Plug a negative 4 in. 81 minus 9 times 16 is negative. And the bottom is always positive. So now, when is the particle moving in the positive direction? In between
Negative 3.
negative 3. When you find it 0, those are the possible turning points. Now, it could have been 0 and just tricked you. And that's why if you make a little diagram, you can actually tell when is it negative, when is it positive. Yeah, great.
It is even. Yeah, so you're right.
Oh, it should be a 6. Yes. I love that. Yeah, come in, Jeff. Real quick on that one problem I was just talking about earlier with the cosines and the sines. This, of course, right here should be a 6. 6 cosine squared plus 6 sine squared makes 6 ones. So that should be 6. Yes. So cosine squared plus sine squared is 1. 9 cosine squared plus 9 sine squared is 9. Yes, that should be a 6. Pass, Jeff. He's a mess. Ooh, oh, back. I don't know. I love myself so much. Did I make it? You never know. And then really quickly up here, this is really silly. This should be a plus right here. Because of course it's natural log over product, it should be a plus. No idea why I made it a minus. I'm averaging about a 97 on my answer keys.
Oh, you converted it. I just used the social myself. You found everything. You want this?
Oh, graphing. Oh,
Like
okay.
so. I didn't know if they were allowed to cross like that. I think
Yeah.
they are.
Oh, yeah, it is.
Yeah, if your velocity is, let's see, how an acceleration positive velocity is getting smaller, but doesn't make any sense. Actually, I mean, they can cross, of course, but not that way. If my velocity is getting smaller, their acceleration should be negative. I'm not sure.
Alright, bro, whatever you want to do.
So my other question is, this is what I got from A and T.
Oh, because I just got the derivative, like this one I simplified it. Oh,
So you see how the same thing,
So it should be the same.
Oh, I see. This is not ATT. This is ATT times this. And this is 360 times that. They're not like terms.
Oh,
Yeah.
okay, thank you.
I don't blame you though. My brain looks for stuff. Yeah.
Because I know that you should run this.
Yeah. Because 1 goes to square root, 1 to the square root is 1, so 6 goes to the square root, 6 to the square root is 6. Yeah. It's like factor 6 out. Yeah. Sure. Does anyone else need a practice test? That would be useful. Yes. Oh, now you can start asking whatever. You sort of evolved into individual things. Alright. So, here's the, let me remind myself, is there something where you yeah. All you need is to approach 4 below. You thought they had to connect somehow in the middle. There's no reason that you can have something come in and then jump. Do they connect? They don't have to. It's a good jump. Yes. One function can be defined. Oh, you That's a good point. The reason I said one function is because people start to draw several graphs. Where each thing is true and each, I'm like, no, I want everything true on one graph. So it should say on one graph or something. Oh, are you, wait. What's your name?
Emmett.
Oh, Emmett.
Yeah, I
Okay.
came in.
I got you. Where are you? There. Oh, for some reason I thought your last name started with a T. And I think that's all I got for you right now. Yeah.
All right, thank you.
Sure. By the way, you guys saw I curved the quizzes a little bit, yes? I didn't say that, but you can see it.
But now number 3. I only did 3. I started to get stuck and I was like, okay.
If you want, what I got for
Do you do
no, I think you can like letter by letter. Yeah, that's why I have like half.
Okay.
So how do you think I could find where to plug the positive?
Oh, yeah.
Same thing. Just say the greater than 0.
So it would be CT X.
Oh. So everything has an output. So the domain doesn't care if it jumps. It just says, is there an output? So everything is negative 10 6. So it should be negative 10 6. Yeah, including 6. It's just, okay.
And then you can do the same graph.
Yep. sure what's happening over there. So from -10 to 6, that's all the inputs that have outputs. I'm not sure what those are supposed to be. Okay. Now the range, there's an issue. There is an output that doesn't happen. Yep, there's an output, so if you want along here, like -8 doesn't happen. I'm not sure why you have 2 8s, from 8 to 8. The lowest possible output is -8, but it doesn't happen, so it should be easy. -8 does not happen, yes. You agree? Yeah. But 8 happens. Now, the more important thing, you're gonna have to erase part of this because is there an output that just does not happen? Look at your open circles. What's that output there? You know, that's the input, what output is it? So does any input have a -4 output? Okay, so you gotta just throw that out. Range has gotta look like this, because there is an output that you have to throw out. So range is a collection of all the outputs that happen. You agree with me, -4 is not an output that happens. No input has that output. So it would be from -8 to -4, parentheses, union, parentheses, -4 up to 8. You have to skip -4, right?
So you will start talking about
No, you gotta solve it. So from -8, then you have to stop at -4. Union, start over again at -4. You go all the way up to 8.
That's why they did it.
Because it's still. Good. So, yeah. Oh, alright, find out when it gets back. I don't know half an hour before it gets back, but I don't know when it gets back. If it gets back in 6 hours, then I'm talking about 5.5 hours, right? And then you just plug 5.5 into velocity. So first thing is, when does it get back? Half hour before that, plug that into the velocity. Do you see the steps? That one's a multi-step problem, right? If you, how do you know half an hour before it gets back if you don't know what time it gets back? Now, your question could right now be, how the hell do I know when it gets back? Alright, so where did it start? Where was the initial positioning? At 0. 0. So now set this equal to 0 to see when is it there again. Yes, solve for t. Ooh, my answer is t equals 0. You already knew that. The other answer is going to be how long it takes for it to get back. And then you go half an hour before that. Yeah. Sure.
You did the homework about it?